you've worked on many sites like this before and done a lot of work using mass engineered timber, CLT, glulam. So any particular challenges of this particular site, this project?
Well, this particular site actually, the design geometry is actually quite straightforward actually, and it's easily anticipated the problems we face, and actually it's quite clear cut actually.
Okay.
Yeah. We've worked on other sites, geometrically challenging structures, where even lifting is lopsided and stuff like that, one-sided weights and all that. Those were a big challenge, and however, it's an exciting challenge.
Yes, good.
Yeah.
And here I noticed we've got curved wood, so this has come like this, right? This has come in
Yes,
this,
yes,
it's already been curved and produced, and then you just have to fit it all together.
Yes, that is correct. All of it curved, pre-drilled holes, pre-cut slots, so we kind of just fit them together and install the fixings. Yeah.
So is it a bit like Lego, you just sort of slot things together, or a little bit more difficult than that?
Well, I think it's better quality than Lego.
And it's timber, of course.
Yes, of course, yeah.
Okay.
In Singapore, I mean, our challenge actually is more of how to protect it for durability.
Yes.
We take it very seriously, understanding timber, yeah, the whole process in building and understanding how we can protect it better from the weather and on the surface also from mold growth and stuff like that, yeah.
So here where you have an overhang that's protecting this doesn't have to be covered, right?
Yes, it doesn't have to be covered, yeah.
And with some of the other buildings, they're all a little bit different. So you followed an architect's design for these, and you hope that all the pieces that arrive from Finland or Austria are going to be cut right and sized right, and then you put them together.
Well, we don't just hope, I mean, we know it will be right, yeah. As for design, yeah, generally we kind of work with the architect at the design stage and clarify about the connection details, whether it'll be aesthetically pleasing and stuff like that. We generally give our suggestions and ideas so that we can be as efficient as possible in the installation methods, yeah.
And do some things delay you in the process? I mean, weather can be a nuisance, of course.
Yeah, that's Singapore, the tropics. It's always the case. We have weather conditions that we have to be cautious about. Okay. But besides that, actually, it's maybe another slight area of focus would be logistics and handling. You know, basically storage of the material close to the proximity of the job site. And in a productive approach, double handling is always it's not advisable. So that's where the challenges come with coordinating with main contractors about available storage space next to the building sites and stuff like that.
Okay. So, I mean, when it arrives on the boat from Finland or Austria or whatever, then you have somewhere where you can temporarily store it until you take it to site? Or is it better to bring it to site directly if you can?
Yeah, we prefer that. Actually, that's our first preferred method is from the port direct to the job site. That way we eliminate a double handle of the material itself. Any handling, there is a risk in damages, and of course there's an exorbitant wastage in productivity, yeah, the efficiency of the movement and all that stuff. So we always prefer to coordinate with the main contractor on the optimum time that they would like to receive the material and the site will be ready for install. Okay. Yeah, with just a bit of buffer time, you know, just for a little bit of hiccups, which is expected through shipping and stuff like that. Yeah.
So Wilson, what's your particular role here? What do you see as your main function on site here?
Okay, basically I'm doing the arrangement of the manpower and planning for the installations to meet the schedules and to make sure the safeties and all coordination starts with our workers and main contractors. Okay.
And have you had any particular problems over the recent months where I know there's been a shortage of foreign labor, there's been shipping problems, any problems that you've encountered that has affected this job?
For the biggest affection for this job, I would see it is the manpower, because we got a shortage of manpower and it seems applied to other contractors. And jobs has been slowing down, and we got a lot of those new regulations for this COVID that we have to apply for.
Okay, so has that delayed this project, the timetable being put back a little bit?
Yes, there is a slight pushback because of all this situation.
And is that coming right now? Are you getting the number of workers that you need?
We are not really towards what we anticipated for the amounts of workers that we require to finish off this job, but we are not too far away.
And have you worked on other projects in Singapore for Ventura as well?
Yes, I've been working for Ventura for other projects in Singapore also.
Okay. And this seems to me a big one because it's got 6 different buildings, effectively. So that requires a bit more coordination and logistical management?
Yes, for sure. Well, we have our own logistic management here, and basically it's our workers and staff who is working closely with the forwarders and main contractors and on the operations to see when is it possible to deliver the materials to site and or for storage.
Okay. And with all the restrictions because of the coronavirus pandemic, even delivery people, I imagine, have to go through checks and swab tests and everything else?
All the basically the forwarder sites, their logistics and the operators, they have to go for this swab test in order for them to deliver the material down to site.
And I was going to ask you, do you like working with wood? Is wood something that you enjoy working with?
Yeah, for sure. we like to work with wood. It's much more easier to work with concrete. They are lighter weights and they tends to be faster.
So normally you're in the office doing the detailed drawings, but you do go on site sometimes to see that everything's working properly?
Yes, sometimes we come here because there is a lot of site planning also that we have to do beforehand. Actually, there is a lot of planning because it's like when the containers arrive to Singapore, and especially the containers arrive to site, we have to have already a plan where to put all the material that they start arriving beforehand, because actually you see our components are very big, like 12 meters or 8 meters long. So it's a lot of space that covers all the site. So we have to also have like a site logistics, where to put this material, where locate before we start installing on the structure. So it's a lot of planning to do.
And is it your job to make sure the architect's drawings from the beginning are followed through, the details are followed through as well?
Actually, my job is more on also with the site team. I help them to do like a 3D of the site, just to figure it out, or to start planning where the cranes can come in, or which is the time. Like the boom lift will start bringing the material, then the crane to the place where is near the structure, if there is a way that the car can come in to pick up the material and start installing, already erecting the structure, let's say. Yes.
Just explain too how the fabrication works. So everything is done to order, if you like, before it's even sent here.
Yes. Everything has to be like actually designed, all the joinery, all the little notch. It has to be all beforehand. Sometimes some components arrive and we try to minimize as much as possible the cutting on site. It always has to be already from the manufacturer. So in a perfect world, we like the material to arrive and just start putting together as it is, without do any cutting or extra job to do.
But if things are not quite right, you might have to fix.
Minor things, normally we do minor cuttings or drill a little bit, but because this is a prefabricated components, it's very good for production, and it saves a lot of time also on site. Normally that's what we work towards, to do prefabricated.
So that's why it's very important to do the planning properly and to specify properly what's required.
Yes, that's right. It has to be like very, very planned before time, like with a lot of time.
And do you like working with wood? Do you like the
Actually, I like a lot because it's a bit sustainable. I mean, against steel or concrete, actually wood is less, for the contamination, is less pollutant than other materials. So I personally like a lot to work with wood, yes. So
this is unusual to me, the shape and style of the construction. But any particular challenges because of that? I mean, you've got the materials all being prefabricated, they arrive like this.
Yeah, that's right. So one of the challenge we have to face is that there was a architectural intention that these outside beams, we call it edge beams, are meant to be curved. So when we go back to manufacture, there are a lot of limitations in terms of the radius you could meet. So we had to work out some design details to meet the architect's intention, still can be manufactured, because there are practical challenges. If you go beyond a certain radius, you can't meet the curvature with natural timber. So we had to make some changes, and we made the architect's requirement, and finally the product is here. So the other challenge is, to answer your question, is that to produce this kind of component, it takes longer time than usual. So the production took probably around 8 weeks plus for these components, where in straight components we can get it done within 4 to 6 weeks once we issue the production drawings to manufacturer.
Okay, because I remember watching Grand Design's program. Do you ever see that program from the UK or Australia? And there, of course, the challenges, and sometimes they were working with prefabricated materials like CLT, like glulam, and of course getting the bend right, but it's a bit of a challenge. It's always a challenge.
Exactly.
And of course some things arrive on site and they don't fit, but from what the others were saying, generally things work out fine as long as things are specified correctly. But and in terms of, and you mentioned before, getting the labor, but for this type of construction, it's less labor intensive. Is that correct?
I mean, that's the whole point of using this technology. The main driver in Singapore to adopt mass engineered timber is to improve the productivity. For example, based on our current product data, we can install about 6 square meters to 9 square meters per man day on the normal geometries like single-story buildings, something like what you see in here. Comparing to other materials using concrete and steel, it takes much more longer because they are not easy to handle. They are very heavy. Just to give example, timber is 1/4 of the weight of steel, including all the connectors, screws, steel plates, etc. So it's much more easier to handle. We often see, if you see over there, next building, you go and say, they're using a lightweight lorry crane to hoist the materials. Where imagine if you had to deal that with steel, it might take longer time, you might need bigger equipment to hoist it.
Right, but you can deal with, and these days, from what I'm reading, mass engineered timber, you can do higher buildings now. I think somewhere in the world they're going to 16, 17, even 20 stories.
I mean, there are studies been done even in locally to go up to 31-story buildings in Singapore. But these buildings will be designed based on the hybrid approach, meaning it will be a combination of timber, steel, and concrete, and so on. Generally, it's ideal to go up to 5 to 6 stories if you're just talking about purely timber. But the moment you go beyond that, we will recommend to go on a different approach, introducing steel and other components.
But you could still have the majority of the content of the materials could be timber.
Could be timber.
But with steel and concrete in support.
Exactly.
I mean, here you have to use some concrete. There's some steel you use for the connections.
Yeah.
What do you call them? The base type. But you'd say what, 90% of the materials being used on this site for these projects is timber?
Within 6 buildings, yeah, it's majority is timber. Okay. Yeah, we're doing 6. Right now we're doing 6 different buildings, 6 MET buildings. And what you're seeing here is just one of the smallest building actually. Okay. And you're going to see much more bigger buildings later on.
So this would be the most complex MET building project in Singapore because it's 6 and different shapes and sizes?
Yeah, I mean the thing is each and every building has a different geometry and it's not repeating each other, right? So when the engineers do design for one building, you cannot apply that to the next building. Right. So you would need to consider each and every building based on the individual requirement, loading, specification, architectural requirements. Right. So it's not easy to deal with 6 buildings at the same time, and you have to install it at the same time. Right now we're doing 2 buildings, installing concurrently. We are short-handed in terms of the labor. However, again, I think it's a very good example because even though we are short-handed, we are on schedule in terms of delivering the project.
You're on schedule.
Yeah. I mean, of course, you have other restrictions. These restrictions will, at the time, in terms of the COVID regulations, I think it's a common thing for all the contractors right now. But we are lucky we are dealing with MET because it's faster to install.
Okay, and so at any one time, how many workers do you have on site besides the management team?
Right now, we only have about 10 workers. It's a very small team actually, but as you see, we are working with 2 buildings. We have about 10 workers and we have 2 to 4 management staff stationed on site throughout the construction period. And we coordinate. The beauty of using MET is that you don't need a lot of information. All you need is to have a proper manual, proper 3D model, and then that goes to the site staff, and then they will use their tablet to determine where the component goes to, and they will carry on with the installation. It's just like a manual, custom made for each building. So, and this is also the first project ever in Singapore we introduced digital construction.
Oh, really? Okay.
Meaning the component we tested as a pilot program for one of the building, P10, it's not been done yet. Each and every component will come with a unique QR code. So that QR code actually refers to the 3D model we generated using a software called ArchiCAD. So what the contractor need to do is, I mean, when they see that, for example, the worker, all they need to do is just need to scan that QR code, then it goes to the model, and they will determine which component goes to which part of the building. So it's very efficient. Rather than in the older days, you had to check the material one by one, the label. I need to go through, 1, 2, 3, that goes there, check against the model, the drawing. Very simple. All you need to do is just take the iPad and then scan it, shows in the model.
Okay.
They will install that. So we're gonna test that on one of these buildings.
Okay. I mean, of course, the workers still have to be supervised, and someone is on site to manage the team.
Exactly.
Of course.
It's very minimal.
But that's an interesting advantage that MET has, that less labour, and by the sound of it, more productive in terms of the better use of labour, and less reliant on a lot of hard labour.
Yeah, that's right.
So what's it like working with Ventura, where they do the timber work, but you still have to make sure it all fits into the overall plan and everything is done right?
Yes, they helped us from the very beginning in the design and coordination phase, and basically also assist us on the production schedules.
Okay.
So we work closely with them to make sure that we prepare the sites for them to come in, and so that the real productivity, like for instance, real productive activities such as erecting columns, beams, are already done on time.
Right.
Yeah.
And one of the advantages of working with timber like this, and particularly prefabricated, is lower labor, less labor intensive. And do you find that an advantage as well?
Yeah, we find that that's good. Okay, for us, while yes, for reduced use of labor, especially in this COVID environment, where there's less worker coming to Singapore. Okay, so one advantage that we really find is the reduced time also. Yeah. So typically, moving up from columns to beams to roof for a single-story building like this will take us close to 3 to 4 months. Yeah, but for them, they complete in a month for a building of this size.
So is a third of the time involved? Roughly a third?
Yes.
So that's good. So do you see the advantage of doing more things, utilising timber MET like this in Singapore?
Yeah, I see there are advantages and probably more scope to come in. Probably a lot more recreational buildings can adopt this facility or this philosophy.
Okay, because cost-wise there doesn't seem to be a big difference now. I mean, initially maybe there's from what Kevin was telling me, maybe 10% increase overall, but if you take into account the reduced labor costs, less time taken to build something, so productivity is much higher. So there are a few advantages, aren't there?
Yeah, I would say, I think if you look at the entire project, or rather for the entire building like this, okay, so the trade-offs in cost will be balanced up with improved productivity, such as savings in time and labor. Yeah.
And the other advantage, I suppose, if we're thinking of the bigger issues, is it's more sustainable. It should be more longer lasting. It's a better option than steel and concrete. We still have to have some steel and some concrete, but if we reduce that, we reduce the embedded carbon in the structure as well, which is an advantage, isn't it?
Yeah. So I think with the world moving towards zero emission, zero energy buildings, I think probably we will see greater adoption of such technologies.
So in the past, where timber was seen maybe as something we feature, we see inside, but using it as part of the structure has added advantages.
Yeah, I would say that generally everything is lighter now, foundation is lighter too, because timber is, as opposed to concrete.
Yes. And one thing I know that BCA has been encouraging this prefabrication, having less time on site. So timber MET seems to fit into that as well.
Yeah, like what I mentioned, for a similar building of this size, if we are to use conventional concrete, it will take us about 4 months to get to the roof.
Okay. Kevin, you've been building timber buildings for a while in Singapore now, so every one of them I know will be different, but there's one consistency, is one obviously the timber, the MET, LET, glulam. So what are the particular challenges of this site and this job?
Well, just going back to your early part of your question, we've been around timber for more than 25 years in terms of the business. Starting off places like the Botanic Gardens headquarters. So for us, this is going full circle, because our first major project in Singapore was the Botanical Gardens headquarters, which was about 3,000 square meters of roof. Principal difference was that it's hardwood. It was hardwood that came from what we understood at that time in the mid-90s was well-managed sources, but we didn't have any paperwork. We dealt with responsible mills and so forth. But that project was really stick by stick, lots and lots of carpenters on site. So a very different sort of experience than we've had as we move forward, you know, nearly 25 years later. Here we are again doing a large project for National Park. Probably a similar scale in the terms of volume of material. Of course, spread over these 5 buildings. And this time, of course, the paradigm has shifted because, of course, first and foremost, we're building with a very productive and sustainable material. Sure. The source of the product is everything, you know. So, of course, the PEFC, and being proud to be the first PEFC COC holder, you know, so that, looking back and contrasting against the Botanic Gardens headquarter, of course, is a huge jump. It's a huge jump in progress. And then once we take on board the mass timber part of it, of course, we've got a technology that's been identified by the government and government agencies as very sustainable. So, you know, as far as the main difference, the physical difference in terms of actually constructing these buildings, is in those days, we could kind of figure out what we needed, order a whole bunch of material would turn up on site, then we'd put together a team of really sort of competent craftsmen, and we had craftsmen from Indonesia, we had craftsmen from New Zealand, and from Malaysia, and from the UK, so, you know, and use their expertise to interpret the drawings and essentially build it on site. Whereas these days, we've done all that work on the computer. You know, we've engineered it and modeled it in software, we've virtually built the building, you know, on the desktop, and then sent all that information to machines, you know, on the other side of the world that have put all that code together and have basically produced precise components. So when those components arrive here, it's the complete opposite, because now we use a well-trained team of installers. They're not craftsmen, you know, they're just basically well-trained installers to put together all these components in a sort of Meccano, Lego type way to assemble these buildings much, much faster than we did in the past, with far fewer people. I would argue much safer, because everything is predictable. And you know, so it's a huge contrast over the last 25 years, and to go full circle with National Park has been really it's quite a privilege, I think.
And I suppose the other big advantage of timber is not only the sourcing of it, but its performance and the fact that it reduces the amount of embedded carbon in a building. How important is this being seen now?
Well, I think, you know, in terms of, we as you know, Ken, we build in Singapore frames, but we are more of an international contractor that specializes in hospitality projects. Most of our projects are overseas. And we're finding now that we've never seen so much interest in terms of where products are from, you know, and obviously with social media and with celebrities talking about sustainability and other topics, the public are a lot more engaged. They're a lot smarter, I would say, because they have a lot more access to information than they used to. And I think that's driving governments and agencies to respond to that demand from the public. I do think that timber construction still has a long way to go in terms of improving that narrative. You know, these days we're in an era of fake news. People don't just believe labels. They want to see proper audit processes that PEFC brings. They want to see visibility where these products are from. And I think that's really, really important as well, because we're talking about a premium building solution. You know, this is not a low-cost building solution. It's a premium building solution, and I think you need to make sure that there's real value in the sustainability. There's a real story that people really understand and appreciate. Yeah.
So, but the carbon component is important, or is seen to becoming more important?
Well, of course. I mean, you know, when we look at mass timber and particularly, you know, these types of massive public structures, that, you know, this is the only material that actually arrives on site negative. Yeah. You know, it's negative. And I think a lot of people don't really understand the impact of that, because they go, oh, it's only offset 200 cars for a year of carbon. you know, or 2 million miles on the aeroplane or something. They don't kind of get their head around the fact that if this was built in steel and concrete, it would have produced 5 times more carbon than its offset. So the difference is between what it could have been and what it is now, being negative. So I think that's something, that's a concept that we're always trying to get in front of customers and the public.
And so I think there is a global trend toward, even from the World Green Building Council, towards net zero emission buildings. So this is in that direction, but also you're sourcing the material in the right way too. So it does seem to have a double whammy benefit for the building industry.
Absolutely, and I think, you know, going back again to the fact that this is a national park public project, there's no better venue for the Singapore government to showcase, you know, that it really thinks about these things. It's important to them in terms of their sustainability roadmap, so to speak. And these buildings demonstrate it. They put it on show. You know, it's something that is very visual. People can see it. They can ask questions. You know, and I think, you know, there's a lot of people out there who still need to understand more when they look at these buildings. Some may react and go, "Oh, you've cut trees down. How terrible!" But you know, of course, we all understand that we're treating the forest the same way we would tend to our garden. We're thinning it out. We're taking those trees that can be removed sustainably and be replaced, and then we're turning it into a 50-year building material. So, you know, I think in terms of the built environment, it's quite a transformative solution. It's just we just hope that there's more uptake and more enthusiasm in building this way.
That's right, and I certainly see that trend happening, and also the advantage of a mass-engineered timber where you can go to increasing heights, so much more of the building or buildings can be engineered and built this way.
Yeah, I think so, and I think, you know, when we talk about building in Singapore and in the tropics, I mean, obviously, for us as an international business building in many markets, I think it's very important to localize the solution. You know, we're not building this necessarily the same way that you would build in Geneva or even in Brisbane. You know, we come up with solutions, and I think it's very important to come up with solutions that are very locally relevant. So, you know, you rely on concrete and steel where it works best, use the timber where it works best, and, you know, come up with a hybrid solution that is very much in tone with not just the physical climate, but also the macroeconomic climate, and of course the development aspirations of the country and or the developer.
So Kevin, I was going to ask you about the sourcing of the wood, the timber that you use. You know, people will say, well, hang on a minute, the carbon footprint must be very high because you're shipping it in from Europe. Do you see a possibility of using timber that has been sourced within Southeast Asia, for example?
Yeah, I mean, that's a great question, Ken, because when we started on our journey, you know, we've been a timber and a resort builder for more than 20 years, but mass timber was only allowed as element of structure about 7 years ago. So that's when our journey started with mass timber here. The first question we asked ourselves, being a business that has a lot of partners around in Indonesia, Malaysia and so on, was can we use products and can we do something else, you know? And that actually we were fortunate enough to convince the authorities here to sponsor some research in that. And we basically went on a journey to look at all the materials around the region and look at their suitability in terms of mass timber. Unfortunately, the result was that these materials, which are commonly grown as plantation species like Eucalyptus pellita or Acacia magnum, these materials are essentially used for paper and pulp. And the way they're harvested is very hard to get solid wood. So essentially, they can produce a lot of timber fiber, but not solid wood. If you look at the structure behind us, you'll see that it's engineered and made up of lots of smaller pieces of solid wood. So that was a real problem. And that meant the efficiency that we could convert those resources was very poor. And it would mean that those plantation owners would then need to harvest in a different way in order to create more solid wood. So that really put most of those species out of the fray. I mean, tropical timber from natural forest, I don't think anyone would go there. It wouldn't make sense. It's too much of a high value material that if sustainably sourced should go into things like joinery and things like this. So we kind of went through that whole process. We actually built some buildings, small buildings with this plantation material and to do a proof of concept, but came to the conclusion that it would be expensive. And if we're talking about the amount of carbon that is utilized in the transport of these materials from Europe to here, it's very low.
Very low.
It's very low. It's only maybe 7% of the offset that is reduced. So that was an issue with that. But I do believe very strongly that the future will be with fiber, you know, because essentially if you could take fiber that's going into disposable materials like, you know, writing paper or toilet paper or other things like this, and you can turn those into 50-year buildings, then that would be transformative. So there is some technology out there. It's still going through licensing process. There's a business in Australia called Lignor that has a process with the eucalyptus. I think there's some university work that's going on even between the local university and Switzerland, which are looking at bamboo and other fiber. So I think, you know, that will be the future, but it's a big investment. It's a quite a long journey because they have a lot of compliance regarding element of structure. You know, as you can imagine, Ken, when you're building a building, you have to make sure that it's very robust and it's very tested. So that's a long process, and then also the compliance and the codes that we work within, particularly in Singapore at the moment, preclude using that product. So I think my prediction is we should see changes within the next 10 years. But in the meantime, we can build beautiful buildings like this with a resource that is sustainable, that's cost effective if you use it in the right way, and, you know, create the market. So if we do, eventually there are these plantation materials that do come into the market, at least there's a marketplace already established for them. Okay. So I think, although the immediate story is maybe a little bit downside, but I think there's a huge upside to come.
Okay.
Yeah.
So that's the future.
That's the future.
Great.